What's up? I'm Vin, and today I want to go through the Algebra 2 August 2022 Regents. So let's get started. So we're going to start off here with the part 1s, and these are 2 credits each. And first up, we have this hot and tasty coffee chain. They're conducting a survey of its customers at a location at the Staten Island Ferry Terminal. And after the survey is completed, the statistical consultant states 70% of the customers who took the survey said the most important factor in choosing where to get their coffee is how fast they are served. Okay, so this is the results of the survey. Based on this result, hot and tasty coffee can infer that. Now, first up here, most of its customers in New York State care about being served quickly. This one I'm going to chop out right away because this was specifically at the Staten Island Ferry Terminal, and there is bias in this survey because they only surveyed people at the Staten Island Ferry Terminal. Coffee drinkers care less about taste and more about being served quickly. That's also not true. The bias here, once again, is if people have to make the ferry, then they care about getting their cup of coffee quickly because they don't want to miss the ferry. All right, so that's the bias in this survey. So most of the customers at the Staten Island Ferry Terminal care most about being served quickly. This one sounds good. Now, most of the customers at transportation terminals and stations care most about being served quickly. This one is like too general. Once again, this survey was conducted at the Staten Island Ferry Terminal, so choice 3 is our best answer. Now, question 2, we have to do a little bit of algebra here, but we should know that I squared is equal to -1. And when we're doing x minus 2i squared, we're doing x minus 2i times x minus 2i, and we have to distribute. So we got x times x is x squared, and then we have minus 2i times x is minus 2ix, and now we're going to distribute the negative 2i. We're going to have another minus 2ix. And then we have minus 2i times minus 2i is a positive 4i squared. And now here what we could do is combine like terms. We're going to have this is equal to x squared minus 2ix minus 2ix is minus 4ix. But now notice here I squared equals -1. So we're going to make this substitution here. And when we do, I'll do that on the side, 4i squared is equal to 4 times -1, which is equal to minus 4. So that's going to tack on a minus 4 at the end. So this is going to match up here with choice 4. Now, common mistake here, please don't do this. So a very dangerous trap would be some students are just going to do x squared plus -2i squared, and they're going to get x squared plus 4i squared, and they're going to write this as x squared minus 4, and they're going to choose choice 2. But just be careful for that. All right, you have to actually distribute here, and you're going to have this middle stuff giving you choice 4. Question 3, we have a function to model the height of a tide in feet, and we want to know what is the amplitude of the tide. Now, when you have a trig function, the amplitude is the coefficient of the trig function. So the amplitude here in this case is 4.8. Just know the pi over 6 on the inside, this represents the frequency, because this would be the coefficient of t if we distribute. And then the plus 3 and the plus 5.1, this tells us here the shift. Okay, this is going to affect the horizontal shift, and this is going to be the vertical shift. But these affect the shift of the wave. Now, if you want a visual of this, just know that whatever your graph looks like, this is not necessarily the function that's going on here. But let me just say I just draw something up here like this. The actual amplitude is the distance from the high point here down to the midline, or I could say the distance here from the midline down to one of these points here. So that's what we're actually finding, but in this case, the amplitude is 4.8. So for question 4, take a moment to read through this. And in watching auditions for the lead singer in a band, Liam becomes curious as to whether there is an association between how animated the lead singer is and the amount of applause from the audience. So he decided to watch each singer and rate each singer on a scale from 1 to 5, where 1 was least animated, 5 is most animated. And he did this for all 5 nights of auditions and found that more animated singers did receive louder applause. The study that Liam conducted would be best described as, so this was just purely observational. There was no experiment done here. Okay, there was no sample taken of a population. Liam just watched the concerts here. And then a random assignment, also not it. This was just pure observation. So question 5, we have to know a little bit of trig here. So we want to find what is the measure of angle theta. And theta is being spun from standard position and terminating at this point A where the coordinates are here. So what you want to do for a question like this, just know this represents your x and this represents your y. So our distance from the origin in the x direction is radical 3 over 2, and our vertical distance is 1/2. So on the side here, I'll just make this a little bit neater. So we're going to have a triangle, a right triangle, and the horizontal distance here is going to be radical 3 over 2. and the vertical distance is going to be a half. And this angle here, I'm going to call theta with the subscript r, because this is going to represent our reference angle. Okay, I'm not going to include the negative here because the reference angle is a positive acute angle. So I'm just going to look at this piece here. So now notice, if the reference angle is here, this side is opposite of the reference angle, and this side here is adjacent to the reference angle. And now what we could do is, if we want to find what is the measure of the reference angle, we could do tangent inverse of the opposite side over the adjacent side. And for this, I would just make sure we're in degrees because all the answers are in degrees. So notice right now I'm in radians, so I'm going to press mode and I'm going to go over to degrees and switch this over. And we go back to the main screen. Tangent inverse is second tan. And if you have trouble writing this in, hit alpha y equals enter, and that'll make a fraction. So in the numerator, we have 1/2. And in the denominator, we have square root of 3. So we press second x squared for the radical, hit the right arrow to get out of it, and then over 2 like this. And now, optional to close the parentheses here, but we press enter and our reference angle is 30 degrees. But be very, very, very careful here, okay? If you're not careful, you're going to choose choice 1, but that's not our answer. This represents the measure of our reference angle. That's this angle here, but we have to think about what is theta if we spin from standard position to this angle. Now, if you know your formulas, the theta in quadrant 2 is equal to 180 degrees minus the reference angle. So this is if you like formulas. But if you just think about it, notice we have a straight line here. And a reference angle is the positive acute angle between the terminal side and the x-axis. So this turns into kind of like a simple geometry question. We have a straight line. This is 30 degrees. So the missing angle would have to be 150 degrees. Or we could say here 180 minus the reference angle was 30. So the angle from standard position is 150 degrees. Definitely choice 4. Question 6, we have this function f of x. We want to know which statement is true. And we have a bunch of answer choices that talk about factors and function values. My first instinct here is to take f of x and factor it. So I have f of x equals, and if we look at the first two terms, we could factor out an x squared, and we're going to be left with 2x plus 1. But notice with the next two terms here, if we factor out a minus 9, we're going to be left with 2x plus 1. So this is going to factor nicely by grouping. And now we could write this as f of x equals, we're going to have x squared minus 9 left after we take out the common 2x plus 1. But now if we factor this further, notice this is a difference of two squares, which I'll abbreviate like this. So f of x, remember your formula for difference of two squares. When you have a squared minus b squared, that factors to a plus b times a minus b. So here we'd have f of x equals x plus 3 times x minus 3. And then we have times 2x plus 1. So now we scan the answer choices. Let's see if anything helps us. 2x minus 1 is a factor is not it, because 2x plus 1 is the factor. X minus 3 is a factor is definitely our answer choice here. Now, why are the other answer choices no good? Well, if we look at this one here, f of negative half doesn't equal f of 3. We'll just know if we were to set this equal to 0, we would get x equals negative half. We would get x equals positive 3 and x equals negative 3 if we set each factor equal to 0. So this would tell us that f of negative half is equal to f of 3 because both of them are equal to 0. And then here f of 1/2 is equal to 0 is not true because f of negative half is one of our roots. So definitely choice 2. So for this question here, we could just type this in the calculator. So let's go to the y equals, and the function was negative and we had log base 100. If you want a custom log, press math, go up to option A, and now we're going to make the base 100. And inside the parentheses was x minus 2. So that brings us here. And now I would just press zoom 6 just in case your calculator is not on that standard screen here. So when we look at this, this is not the nicest picture in the world. But if we match this to one of the answer choices, I think we could see that this is mostly resembling choice 4. Now the calculators are not perfect, but what's going on here is that we actually have a vertical asymptote at x equals 2. So this is like wanting to, I'll draw this a little bit nicer, is it's trying to climb up here towards the vertical asymptote like this. So that's why it's matching this one. But let's say if you just know transformation of functions here and you want to do this without a calculator, what I think of in my head is I just think of any old log function, but let's just pretend, okay, I start with log base 100. So I have log base 100x. This is going to have a vertical asymptote on the y-axis and it's going to go like this. But when we multiply the front by -1, and I want to graph this function, okay, that's going to take the function and it's going to reflect it over the x-axis. So this one here would actually go something like this. So the y-axis is still an asymptote, but now it's going to go kind of like this. All right, it's going to go in this direction here. But now the last thing is what happens when we replace x with x minus 2. This is going to move the graph 2 units to the right. So let's see if this is, oh good, it's disconnected. So it's going to go 1, 2 over like this. And let me see if I could take this piece with it. So I'm going to move that with it like this. So this would be, once again, if we replace the x with x minus 2, it's going to shift it over 2 units to the right. So that's why it's matching choice 4. Question 8, we want to know which equation has these roots. This is all calculator work. So I would go to the main screen and I would go to mode and make sure that you're in complex number form. So you see we're in real. We'll switch over to a plus bi so we could punch in these imaginary numbers. And now what I'm going to do on the main screen, I'm going to write 3 plus I, which I is second, and then we have the decimal here. And I'm going to press the store button, and I'm going to store this as the letter A. That way you don't have to keep writing 3 plus I each time. And let's say I plug it into the first equation. I would have this. I would have a squared. So I have a squared minus 6a, and then plus 10. And let's see if this works out to 0, and it does. So this one's already looking good, but now let's see if I have 3 minus I. 3 minus I, I'm going to store this as the letter b. And see if this checks out with the next equation. I'm sorry, with the same equation, because it has to be true for both of them. So now I would have b squared, and I would have minus 6b, and then plus 10. Notice I get another 0. So choice 1 is already it, but let's see why the other choices are no good. So I'm just going to test it out for choice 2, but theoretically, like, you have 3 hours to do your regions, so you could just plug these into the others. So let's say I plug a into the second equation. I would have a squared, but this time I'd have plus 6 times x, so I'd have plus 6 times, and we're plugging in the root that we stored in a, and then we have minus 10. And notice this time I get 16 plus 12i, so that's why 3 plus I is not a solution to the second one, and a similar process will rule out choices 3 and 4. So 8 is definitely choice 1. So take a moment to read through 9. We have a university with, right now they have 12,000 students, and the enrollment is increasing continuously. This is telling me that we're going to use APERT, A equals PE to the RT, like this. And the rate is 2.5%. So 2.5%, just know 2.5% is the same thing as 2.5 divided by 100. And that's the same thing as 0.025, like this. Okay, so I'm just converting this here to a decimal. And what we want to know is which logarithm is equal to the number of years it will take. So basically, we need to solve for t. It will take for the population to increase to 15,000 students. So just so you know here, like, this represents the initial population. Okay, so this is the initial population. And then A represents like the new amount after a certain amount of time. So here, the new amount is going to be 15,000. And that's going to be equal to the initial amount. So this is like our capital P is 12,000 times e to the r is 0.025 times t, like this. And notice all the answer choices have natural log in them. So that's the algebra we're going to do at some point. So first I would divide by 12,000. And you could use a calculator here, but when you have common zeros like this, the common zeros just cross off. And then I would divide the top and bottom by 3, and that would tell us, or notice here they write it as a decimal. So 15 divided by 12 is the same thing as 5/4, which is the same thing as 1 1/4 or 1.25. So we'd have 1.25 equals e, and I'll leave a little space for the next line, to the 0.025t. Now what I would do is I would take natural log of both sides. So some algebra that you need to know for this, and let's make that a little bit neater. So natural log of this side. Just know big ideas, that natural log of e to the x is equal to x, and also this one, e to the ln x equals x, because e and natural log are opposites. So that's kind of like what we're doing here is natural log and e are going to cancel. And this is going to give you, you're going to have ln of 1.25 equals 0.025 times t. So then t, what we're solving for, we divide by this. And that's going to give us, when we're all simplified here, t equals ln 1.25 over 0.025, which matches choice 4. Question 10 you could use a calculator for, unless you know what the graphs look like. So this I would divide both sides by x first, and that would give us y equals 20 over x. So what we're going to do is we're going to sketch both functions, but we're going to sketch them on the same set of axes. So what we have here, 20 over x is going to look something like this. So this is a graph of 20 over x. Now e to the x is an exponential function, and it starts off like kind of flat here because it has a horizontal asymptote, and then it picks up like this. So one thing to know about e to the x is that e to the x is greater than 0 for all x. Okay, this is true for all x. So it's always in quadrants. This function here is in quadrants 1 and quadrant 2 only, whereas this function, 20 over x, sits in quadrant 1 and quadrant 3. So the quadrant 3 part of the graph is never going to interact with this part of e to the x going this way, because the x-axis is a horizontal asymptote. The red curve is never going through the x-axis to cross this blue curve over here. Okay, they're never going to meet. So that tells us that we're going to have just one point of intersection here. So definitely choice 1. Question 11, we have this function here. We want to know which statement is false. So here, for choice 1, in 20 days, there is no substance remaining. Well, this one already seems kind of strange because we have an exponential function here, but it's like an exponential decrease function. So we have something that's starting off with an initial amount, and then it's like decreasing over time like this. So if we think here in 20 days, and t is modeled in days, we would have a of 20 is equal to 50 times 0.5 to the 20 divided by 3 power. So right away, even though we're multiplying 50 by 1/2 a bunch of times here, the concept is that this curve will never hit the x-axis, or in this case, the t-axis. So if this represents a of t, we're never going to quite reach the t-axis, even if we were to go out to infinity here. So we'll never have truly no substance remaining. So this one already is false. But when your first one is false, I kind of like to rule out the other ones or show that they're true so that I feel confident in choice 1. So here, after 2 half-lives, there is 25% of the substance remaining. That makes sense because think about it. Like, imagine it was pizza. If you have a pizza pie and you cut it in half, and then you cut it in half again, notice that it cuts it into 1/4, or it cuts it into 25% slices here. So this one is definitely true, so we're going to cross off 2. Now, choice 3 is just algebra, that the function could also be modeled this way. This one is true because if I rewrite the original as 50 times, instead of 0.5, I call it 1/2 to the t over 3. What you have to know is that 1 over 2 is the same thing as 2 to the negative first power. So this would be 50 times 2 to the negative first power to the t over 3 like this. But just know another rule of algebra is that when you have a power raised to another power, this we could call a to the b times c. So now if I multiply, I have 50 times 2 to the negative 1 times t over 3 would be negative t over 3. So this is definitely true. So that's going to rule out choice 3. But now for choice 4, this one I would use a calculator to verify. After 1 week, which would be t equals 7, because t is in terms of days, there is less than 10 grams of substance remaining. So we could just plug into this equation here. We have 50, and now we have 1/2, or originally it was written as 0.5, but it doesn't matter, to the power, and then t equals 7, so we'll have 7 divided by 3. And if we get something less than 10, then 4 is true. And notice we get 9.921, which is definitely less than 10. So 4 is true, which allows us to eliminate it. So 4 crosses out, definitely choice 1. Question 12, if you know the concept of what a parabola is based on the definition of what a vertex, focus, and a directrix is, this allows you to answer this choice just by process of elimination. So when I have a parabola, what I know is that the focus is this point here above the vertex, if it's a parabola opening up, a positive parabola like this, and the directrix would go underneath like this. So this would be the directrix. Otherwise, if I had something like this, like a sad parabola, then in this case, the focus would be here, and the directrix would be the line going over like this. Because the concept of a parabola is that it is the locus of points, or set of points, that are equidistant from the focus and the directrix like this. So any point xy is the same distance away from this point and this line like this, whether or not we're opening this way or if we're opening this way. So using that idea, now we look at the question. The vertex is at 2, 1. So we're going to the right 2, and we're going up 1. So this is our vertex. So I'll just label this here as our vertex. And the focus is at 2, negative 3. So just sketching something out here like this. So this is our focus. So this is a situation here, if we think about this carefully, where our directrix, notice that the distance from here to here is 4. So if I went up a distance of 4 this way, that would bring us up here at 5. So our directrix would be over here at the line y equals 5. And now what we have is our parabola. This is not drawn to scale, by the way. This is just helping me answer the question without doing much work. Is going to open down this way. Okay, so something like this. Now, in general, the vertex form of a quadratic equation is in the form a times parentheses x minus h squared plus k, where the vertex is h comma k like this. So the fact that the vertex is 2, 1 tells me h is 2 and k is equal to 1. So right away I could see our equation is going to be in the form of a number times x minus 2 squared, and then we're going to tack on plus k or plus 1 like this. Now another thing is that this parabola here, a is going to be less than 0 because it's opening downward. So I'm looking for an answer choice that has a negative a value. So right away that eliminates choice 1, because notice here that this a value is greater than 0. So this one's out. Now when we look at the remaining ones, we need something in the form of x minus 2 squared plus 1. And out of all the remaining answer choices, 3 is the only one that has a negative a value and is in the form x minus 2 squared plus 1. This one would have a vertex of 2, negative 3, so that would be no good. And this one, the vertex would be negative 2, negative 1, which wouldn't match this vertex. So that's why these two choices are out. Definitely choice 3. Question 13, it helps to know this rule. When you have radicals with the same root in front, you can combine them into a single radical like this. So for this question, that's what we want to use. We have a times, and then we have the cube root of 2b squared times the cube root of, we have 4a squared b. So for this question, what I would do is I would combine these into a single radical. And we would have a times the cube root of, and we'll have a big radical here. This is going to be 2b squared times 4a squared b. And now just multiply the like terms. So this is going to be a times the cube root of, we have 2 times 4 is 8, and then we have a squared is by itself. B squared times b will make b to the third. And now this, we could use this rule but backwards. We could split up into individual radicals. And the reason why I'm doing this is just so that it makes more sense. Honestly, I would probably skip this step though. If you're really comfortable with this topic, then you could just do the algebra faster. But this is the same thing as cube root of 8 times cube root of a squared times, and then we have the cube root of b to the third. So I'm just separating this product here. We have the product of 3 things into their own separate radicals. So now we have a times the cube root of 8 is 2 times the cube root of a squared, doesn't simplify nicely, and the cube root of b to the third is b. So now this is going to be 2 times ab times the cube root of a squared like this. So now I scan the answer choices here, and this one is looking like choice 1. We have 2ab cube root of a squared. So this one here, it helps to know transformation of functions. Otherwise, just use the calculator. But I think about what does 3 to the x look like first. And this is an exponential function, and it goes like this. And just know the horizontal asymptote is the line y equals 0. Okay, y equals 0, or the x-axis, we could say. So if we slide this thing 1 unit to the right, that's what the x minus 1 is going to do here. When we replace x with x minus 1, this is going to slide this thing 1 unit to the right. So this point here is 0, 1, is going to move over to 1, 1 like this. Okay, so that's the only change here when we slide this to the right. The horizontal asymptote is not going to change, but that point is going to move. And now this piece though, the plus 2, is going to have an impact on our horizontal asymptote, because now what's going to happen is we're at, like, this is the point that I'm following, 1, 1. And we'll just make that a little bit neater. So the point 1, 1, when we go plus 2, that's going to move it to 1, 3. So now in the final version of this, 3 to the x minus 1 and then plus 2 is going to move everything. The entire graph is going to go up 2 units. So now we would be at the point 1, 3 like this. Like, this is the point to follow, and our graph would look something like this. But notice, if the horizontal asymptote is still at y equals 0 at this stage, now it's going to move to the line y equals 2 like this. Okay, so the new horizontal asymptote is going to be at y equals 2. So now as x goes to negative infinity, this means go far left. Okay, we're going to go far to the left. What is happening to our y value here? So let me just make this a little bit neater. So what's happening to the y value as we go all the way to the left? The y value is heading towards our horizontal asymptote, y equals 2. So that's going to lead us here to choice 3. Now let's say you're looking at that like, no way I want to do that by hand at the Regents. Then just do this, 3 to the x minus 1. And let's just make sure we type this carefully. So 3 to the x minus 1. And then we've got plus 2. And now I'm going to press zoom 6 like this. So notice our graph. It might be a little bit tricky here to see what's going on. But what you could do is you could press second graph and then just start scrolling up like this and see that, okay, as I go all the way to the left, my y values are stopping at 2. And if we were to graph the line y equals 2, just to see, you could see here that the graph, the calculator does as best as it can, but the graph here is getting cut off at the line y equals 2. So as we go all the way to the left, y, or we could say f of x, is heading to 2. For question 15, for the values of x for which the expression is defined, this is equivalent to. So this one, my first instinct is to factor. So on top, I would factor with a GCF. The greatest common factor would be x, and we would be left with x plus 3 after we divide each term on top with x. And now on bottom, I would be looking for two numbers that have a sum of 5 and a product of 6. And those two numbers would be 2 and 3. So it would have x plus 2 times x plus 3. And notice we have matching factors, so the x plus 3's cancel, leaving us with x over x plus 2, and this matches choice 2. Question 16, we have a recursive formula for the sequence is, and for this one, when I hear the phrase recursive, automatically what I'm thinking of is that we're going to have some formula with a bunch of stuff, but at some point the right side needs to have an a sub n minus 1. So notice choice 2 has it. A sub n equals, we have a sub n minus 1 minus 16, and also choice 4 has the a sub n minus 1. Choices 1 and 3 do not have a sub n minus 1 on the right side, so they're out automatically. Now this, if we look at the sequence, it's going down by 16, and then to get from here to here, it's going down by 12. So right away, I can see this is not an arithmetic sequence. So that means we're not decreasing by 16 each time. So automatically 2 is out, and it's definitely choice 4. But if I really want to confirm why it's 4, this is a geometric sequence. And what we could do is we could solve for r. R is equal to the quotient of any term divided by the one before it. And if we do 48 over 64, divide top and bottom by 16, this reduces to 3/4, or we could say 3/4, which equals 0.75. So you see why it's matching choice 4. And if we want to check, we could also do 36 divided by 48. This one divide top and bottom by 12, and this time we also get 3/4, which is 0.75. So choice 4 is looking good. Question 17, if you don't know how to do polynomial division, there is a sneaky solution to this. What you could do is just plug in x equals 0 to the question and the answer choices and see what you get. And notice you'd have 0 to the third minus 2 over 0 minus 2 is equal to negative 2 over negative 2 equals 1. And now if you plug in 0 to all the answer choices, see 1, you'd get 0 squared equals 0. That doesn't match 1, so this is out. If you plug in 0 to the second one, so let me just fix this here. We'd have 0 squared plus 2 times 0 plus 4 plus 6 over 0 minus 2. And this would be 0 plus 0 plus, we'd have 4. And then 6 divided by negative 2 is minus 3. And this equals 1. So this one maybe is our answer choice. So it's a contender. Now 3, if we plug in 0 for 3, that's going to give us 0 squared minus 2, which is negative 2. That doesn't match 1, so this is out. And then choice 4, we do the same thing. We have 0 squared minus 2 times 0 plus 4 minus 10 over 0 minus 2. This cancels, and this is 4 minus 10 divided by negative 2 is negative 5. And 4 minus minus 5 is 9, which does not match 1. So just by the sneaky solution, it has to be 2. But now let's say you want to do this the long way and you actually want to do polynomial division, because if this is a part 2 question, you actually have to show your work. So here what you could do is you could write this as x to the third, and let me write this as 0x squared, and then 0x, and then minus 2. And the reason I'm doing this is so that the placeholders don't throw us off. If we divide by x minus 2 like this, what we're going to have is x goes into x to the third, x squared times, and we'll have x to the third, x squared times minus 2 is minus 2x squared. And now we're subtracting. So we're going to subtract this, and when we do minus minus 2x squared, it's going to change to plus. And now these terms are going to cancel, and we'll have 2x squared. We bring down the 0x like this. Now we start this process all over. We're going to have next, we're going to have 2x squared divided by x is 2x. And now 2x times x is 2x squared. 2x times minus 2 is going to give us minus 4x, and then we subtract. So we do minus this, and then minus the minus 4x changes this to a plus. And we'll have 4x, the minus 2 comes down. And now x goes into 4x 4 times, with 4 times x is 4x. But then when we do 4 times negative 2, that's negative 8. So when we subtract, notice we're going to have minus, and this will change to plus. We're going to have a remainder of 6. So this is plus 6 is our remainder, and we divided by x minus 2. So this is the long way to get there, but this gives us choice 2. Question 18, I'll show algebraically, and then I'll show you some calculator magic. But first, if we're doing this algebraically, what I like to do is say which values of k cannot be part of our solution set. And I target the denominators of the fractions. We're not allowed to divide by 0. So right away I could see that k cannot be 2 because 2 minus 2 would give us a 0 denominator. And then this factor is going to tell us k cannot be 6. So right away, looking at the answer choices, if k cannot be 6, choice 1 is automatically out. So this one's a very dangerous trap that we have to look out for. Now, look, if we really wanted to, we could just plug in the values of x here and see which ones make this equation true. But we'll go ahead and practice the algebra just in case this shows up in part 2. So we've got 4 over, and we've got k squared minus 8k plus 12. Now this one here, I'll just do this in one step, is going to factor nicely. This is going to factor to k minus 6 times k minus 2. Now the giveaway here is usually they're going to make the factors of this match the factors of the other two. So what I'm going to do now is I'm thinking least common denominator. I have k over k minus 2, and I'm going to multiply this first fraction by k minus 6 over k minus 6. And then the second fraction here we have plus, and we have 1 over k minus 6. This one we need to multiply by k minus 2 over k minus 2. That way we have matching denominators. But now once all the denominators match, we could just cross them all out like this. So this bottom row just essentially wipes out. And it leaves us, we have 4 equals, we have k times k minus 6, we just distribute. That's going to be k squared minus 6k. And then we have plus 1 times k minus 2 is k minus 2. So now we've got 4 equals k squared minus 6k plus k is minus 5k. And then we just tack on our minus 2. So then I would do minus 4 on both sides. And we'll make space over here. We're going to have 0 equals. So I know I'm just kind of going on a slant here, but we have k squared minus 5k minus 6 like this. And now we have 0 equals, this will factor to k minus 6 times k plus 1. And check it out. We get two solutions, k equals 6, k equals negative 1. But this is the dangerous trap we talked about. K cannot be 6. We have to reject this. K equals negative 1 only. Now, what we could also do is type the left side of the equation in the y1 spot and the right side in the y2 spot. And if you press graph here, this is what the picture is going to look like. But if we go to the table here, notice at k equals negative 1, we have matching y values here. So k equals negative 1 is one of our solutions. And of course, I wrote this in terms of x. But one thing to check out here is that x, or k in this case, equals negative 6 was one of the potential solutions. But notice the y values don't match. So that wouldn't be counted as a solution here. K equals 6 gives us an error. And then at k equals 1, notice the y values of both graphs don't match. So that tells us right away that k equals negative 1 is our only solution. Now, question 19 is kind of a strange question here, but we have this polynomial, and we want to know which equation must also be true for all values of x and y. So we're given this identity here, and we want to see which answer choice is also equivalent. So just looking at this, choice 1 is jumping out at me as our answer right away. And what's going on here is that they're actually distributing this polynomial on the right to the binomial here on the left. So if we were to do that, notice we would have x squared times x to the 4th minus x squared y squared plus y to the 4th. And then we would have that same polynomial times the y squared component like this. So that's how I know this one is good right away. Now, what's wrong with this one? Well, this one here, the problem is how they chose to factor this polynomial, which I'm underlining here in black like this. Because if you were to expand this here, if you were to do x squared minus y squared times itself, x squared minus y squared, yes, you would have x to the 4th in the beginning, and you would have a y to the 4th at the end. But you would have a minus x squared y squared and another minus x squared y squared like this, which would make minus 2x squared y squared, which doesn't match the minus x squared y squared they start with. So it's off. The coefficient is off by a little bit, so this one's out. Now this one is kind of like another funny trap here. Just be careful. This is not equal to x to the 6 plus y to the 6. This is a common mistake, is that people see things like this and they're like, oh yeah, a plus b squared is a squared plus b squared. And that's, once again, another dangerous trap. There's the middle term here, the 2ab. So this one kind of ignores the idea that when you square a binomial, you're multiplying it by itself and you're going to have a middle term. So let's just, we'll make that a little bit neater here. So we're going to have a middle term. In this case, if we do x to the third plus y to the third, and we're multiplying it by itself here, we're going to have a 2x to the third, y to the third in the middle. So this one does not match. And now this last one here, let's see. Well, okay, this is like another common mistake in algebra, is that people think when they have this equation here, so let's write it in a new color. If we have x to the 6 plus y to the 6 equals this here, and I'll just kind of stop at this part, like minus dot 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 like that. You can't simply just go ahead and subtract this on both sides. The reason being is that this is attached, so this one is attached by multiplication, which we'll just abbreviate here. So you can't just subtract the x squared plus y squared to the other side like this because it's attached by multiplication. So that's why choice 4 is out. Definitely choice 1. Question 20, use the calculator, but make sure you are in radians because that will affect things. So we're going to go to y equals. We're going to clear out our stuff from before. And we've got 3 sine. And then we've got, I'm going to write 0.5 instead. 0.5 instead of theta, we'll write an x. And now we're on the interval from negative pi to pi. So I would press window. I would clear out the x minimum. And I would change the x minimum to negative pi. And I would change the x maximum to positive pi like this. So now if we press graph, let's see what this looks like. Well, let's describe this function. Just by what we're looking at, notice this function is strictly increasing the entire time on this window here. So choice 1 is out. Decreases then increases is not true. This thing is just going up. Decreases throughout, increases throughout is, so choice 4 is our answer, but increases then decreases also doesn't make sense. So definitely choice 4. This graph is increasing throughout the whole interval. Question 21, a company is firing people to save money, and this is how much money they saved over the course of 5 years. We want to know which expression determines the total amount of money saved by the company over 5 years. So what we could do is just add these 5 numbers up and then see which answer choice using the calculator matches the sum of these 5 numbers. So this is the sum that we're targeting. And now if we go through the answer choices, our first answer choice was in the form of a fraction here. We have 59,000. So not going to press the times button. We have 59,000. And we write minus, and we have 59,000 again. And we've got 1.1 to the 5th power. Now in our denominator, what we could write, we go down, and we have 1 minus 1.1. And if we press enter here, notice we get a matching amount here. So this is without knowing any formulas. You could just solve this by brute force. Now, let's say I were to try out choice 2. So I'm going to press enter on what we typed in. And let's see why choice 2 is no good. So in place of 1.1, notice there's a 0.1. So I'm going to type in a 0. And then the other thing that's going to change down here is we're going to have 1 minus 0.1. But when we punch this one in, notice we get an amount that doesn't match 360,290 cents. So that one's off. Now, if I want to check choice 3, I would just press math and I go up to summation here. So that's a summation. Now I could use n if I really want to match the question here. I would just press alpha log and that's going to pull up an n. And we're going from n equals 1 to 5. And we've got 59,000. And now we're multiplying by 1.1 to the n. Okay, so once again, we could just punch in all of these answer choices. And it doesn't take that long to do this, but notice this doesn't give us an amount that matches either. And if we do this one more time, except this time we make it a 0.1, and our exponent is an n minus 1, notice this doesn't match the sum either. Okay, so once again, choice 1 is looking good just by using the calculator. So choice 1 is our answer. Now let's say we want to use a formula. The sum of the first n terms of a geometric series is equal to a, which is the first term, times 1 minus r to the n divided by 1 minus r, where r is the common ratio and n is the number of terms that we're adding. So here, our first term, our a value, is equal to 59,000. And now our r value we could find by dividing any 2 consecutive terms. But when we divide, let's say, 64,900 by 59,000, this is going to be equal to 1.1. So then here what we're doing is we're finding the sum of the first 5 terms here. So let's make that a little bit neater so it looks like a subscript. So we're finding S sub 5, and this is going to be equal to 59,000 times, and we have 1 minus R is 1.1. N in this case is equal to 5. And then we're dividing by, we have 1 minus R. And you can see right away that if I were to distribute the 59,000, this is going to match up with choice 1. Question 22, we have a train that's arrived on time 64 of its first 80 days. Now, as the arrivals continue, we want to find the equation that can be used to find X, which is going to be the number of consecutive days the train must arrive on schedule to raise its performance rate to 90% on time. So for this question here, what I would think about is 64 over 80. This reduces to 8/10. We could reduce it to 4/5, but 8 out of 10 tells us 80%. So we want to raise our performance rate from 80% to 90%, and this is our original fraction that we're starting with. So we have to come up with an idea on which equation needs to be set up. Now, what you could do is just think about this. If the train shows up on time, that's 65 times it's on time out of 81 days. So this is on the next day it shows up on time. And then it shows up on time again. That's 66 times it was on time out of 82 days. And this trend would continue until we get to the desired 90%. But think about it. This was starting at 64 out of 80, and then we're just adding. Notice here that this is a situation where X equals 1. We're just adding 1 on top, and then we also have to add 1 on bottom. Here, this would be X equals 2, and we would do 64 plus 2 is 66. 80 plus 2 is 82. So when we get to this day, the Xth day, all right, this is the Xth consecutive day, is when we reach 90%. And 90% is the same thing as 90 out of 100. So once again, this would be X equals 1, X equals 2, and so on. But on the Xth day, when we reach 90%, we would be able to set this fraction equal to 90 over 100. So now we just scan the answer choices here. And notice this is going to match up with choice 2. Question 23, we want to know which statement is true of the inverse function f inverse of x. So when you're looking for the inverse function, what you should do is switch the x and y. So instead of saying y equals this, we're going to have x equals negative 2/5 y and then plus 4. And then once you get to this step here, the goal is to solve for y, and that's going to tell you your inverse function. So what we could do is we're going to do minus 4 on both sides. And at this step here, we're going to have x minus 4 equals, and we're going to have negative 2/5 y. And now if we want to solve for y, what we could do is we could multiply both sides by the reciprocal. And the reciprocal is, we could say, negative 5 over 2. Now some people might say, wait a minute, why isn't the negative attached to the 2 on bottom? Just know that negative 2/5 is the same thing as 2 over negative 5, and that's the same thing as negative and then 2/5. So that negative sign is pretty flexible, but we're going to multiply the left side by negative 5 over 2 as well. On this side, a negative times a negative is positive, and then these terms here are going to cancel each other out because they're reciprocals of each other. So you have y equals, and now when we distribute, this is going to give us, we're going to have negative 5 halves x plus, and then if we do on the side 5 halves times 4, just know this, we could just call this 4 over 1, and we could multiply across the top, or we could do 4 divided by 2 is 2, and then 5 times 2 is 10. So that brings us here, and right away I'm seeing that our slope is negative 5 over 2, and our y-intercept is equal to 10. So now let's look at this, and this is, once again, this is our inverse function, what we just found. So this is f inverse of x. So f inverse of x is a line with slope 5 halves. That's not true because the slope is negative 5 halves. This is a line with slope 2/5, also not true. This passes through the point 6, negative 5. All right, well that I would have to verify here. If we plug in x equals 6, notice x equals 6 gives us y equals negative 5 halves, and then we multiply by 6 and we add 10. 6 divided by 2 is 3, and this would give us negative 15 plus 10, which is equal to negative 5. So notice when x equals 6, y equals negative 5. This one checks out. But now what I would do is just rule out the last one. The y-intercept is at 0, negative 4. The y-intercept was 10, not negative 4. So that means this one's out. Definitely choice 3. So question 24, we have the amount of substance A of t, and here's the equation for it. And we want to find an equivalent form of this equation. Now, there's 2 ways we could go about this. We could just type in the original equation in the calculator, and then we could type in all the answer choices and see which ones match. Or we could go through a more technical solution. So we could write a of t equals, and we have a naught times. And what I want to do a little bit different here is we're using this rule of algebra, that a to the b to the c power is the same thing as a to the b times c. So what that allows us to do then is we could rewrite this as 0.5. And instead of writing this power here as t over, I want to point out that t divided by 0.0803, this is the same thing as 1 over 0.0803 times t like this. Like I could separate this, and this is perfectly valid. So what I'm going to do is I'm going to use this rule over here in a really creative way. We're going to rewrite this as 0.5 to the 1 over 0.0803 power, and then we're going to raise all of this to the t power, because notice, if we were to multiply this term here by this term here, it would bring us right back to where we started. We would be right back to t over this. So that move there was perfectly valid. But now what we want to do next is we're going to type just this part here right into the calculator, and this is going to give us a formula for a of t that's going to be equivalent to the original. So let's go ahead and do that. So I need to know what is the value on the inside of the parentheses here. So we have 0.5 being raised to the 1 over, and we have 0.08 and then 03 like this. And now we press enter, and notice we get this decimal value here. Now this, just in case you're not used to this notation in the calculator, this means this value here is the same thing as times 10 to the negative 4. So what that allows us to do is we could convert this now from scientific notation back to just standard form here. And what I'm going to do is I'm going to add a few zeros like this, because when I multiply by 10 to the negative 4, that's going to move the decimal 4 places to the left. So we're going to go 1, 2, 3, 4. So our actual decimal would be 0. We would have 3 zeros, and then we would have 178,313, and so on like this. And now when we look, notice this is what's going inside here. We have the 3 zeros, 178,313 like this, and this is going to match up with choice 1.